स्क्रीन विजिबल है आप सबको?
Yes, sir.
ओके। ये न्यूमेरिकल हमने लास्ट टाइम सॉल्व कर लिया था, आयरन वाला। सो लेट्स सॉल्व द नेक्स्ट न्यूमेरिकल। सो चैप्टर 4 के ही दो न्यूमेरिकल्स, दो या तीन न्यूमेरिकल्स जितने भी पॉसिबल है इस टाइम में, वी शैल सॉल्व। So here you see 680 kilograms of fish at 5 degrees Celsius are to be frozen and stored at minus 12 degrees Celsius. So we have fish available at temperature of 5 degrees Celsius, and we need to cool this fish from 5 degrees Celsius to minus 12 degrees Celsius. Right. So let me show it. So initial temperature is 5 degrees Celsius, and of this 680 kilogram of fish, and its temperature is to be dropped till minus 12 degrees Celsius. The specific heat of fish above freezing point, because there will be somewhere a freezing point of fish, because at this temperature, at 5 degrees Celsius, fish is not freezing, right? So there will be a freezing point of fish, which is minus 2 degrees Celsius. That is given here. So minus 2 is somewhere here. That is the freezing point. Okay. So the specific heat of fish above freezing point. So for this region, 5 to minus 2, the specific heat of fish is a combination of liquid and solid. So it's not a gas. So there is no need to write Cp or Cv. So it's just C, specific heat, and that is 3.182. And below freezing, and Cp value below freezing for this range, C or Cp or Cv is 1.717. Units for both C's are kilojoules per kilogram per Kelvin. The freezing point is minus 2 degrees Celsius. So this is freezing point FP. And the latent heat of fusion. So because during freezing, the amount of heat which is taken out at minus 2 degrees Celsius, when temperature will not be changing, only phase will be changing. So during this phase change process from a solid liquid mixture to pure solid, so during this point, when it is freezing, the latent heat of fusion, H, we will represent HF or HFU, H fusion. Okay, so do not confuse it with HF and HFG. Those are for liquid and gaseous region. So here it is H fusion, FU. That is given as 234.5 kilojoules per kilogram. Because during phase change process, temperature will be constant. So that's why you do not see here per Kelvin, per degree change in Kelvin, which is the definition of specific heat. So we cannot use this specific heat during phase change process. During phase change process, it is the heat which is taken out from this fish. That heat is actually the latent heat. It is not sensible heat. So now there are two sensible parts from 5 degrees Celsius to minus 2 degrees Celsius. And then from minus 2 to minus 12, there is another sensible heat part. And at minus 2 degrees Celsius, there is a latent heat part. So two sensible heat transfers and one latent heat transfer when the fish is changing phase. Okay. So now we need to determine how much heat must be removed to cool the fish. So the total heat which must be removed by dropping its temperature from 5 degrees Celsius to minus 12 degrees Celsius. So the total heat यहाँ से हमें remove करनी है, that is to be calculated. So this total heat removed, Q removed, is to be calculated. Because once we know how much Q to be removed to cool 680 kilograms of fish from 5 degrees Celsius to minus 12. So when we know this heat, total heat to be removed, then we can make or we can design a refrigeration system which can remove this much heat. आप जब मार्केट से कोई रेफ्रिजरेटर या एयर कंडीशनर परचेज करते हैं, so every refrigeration machine has a cooling power. So what is that cooling power? That is represented in terms of tons. So what is ton? Ton is actually, you will read or study in refrigeration and in air conditioning, 1 ton is actually equal to 3.5 kilowatts. So when we say our refrigerator has a capacity of 1 ton, it simply means that it can absorb 3.5 kilowatts of heat from this space to be cooled. So we should know how much heat should be removed from that space to be cooled so that its temperature can be maintained at the desired temperature. इसी को आप इस क्वेश्चन में देखें, यहाँ पे भी हमने यही डिटरमिन करना है कि 5 डिग्री सेल्सियस से लेके minus 12 degrees Celsius तक टेम्परेचर ड्रॉप करना है. Then how much heat should be removed, Q removed, for this 680 kilograms of fish. Then we can design or then we can purchase directly from the market the refrigerator or air conditioner of that capacity. So we need to determine that capacity, how many tons or how many kilowatts or how many BTUs per hours has to be removed. Okay, so this is the question. So now we shall solve it. So heat to be removed above freezing point. So we will calculate the heat which is removed during this part by dropping its temperature from 5 to minus 2. And then at minus 2, how much heat has to be removed. And then from minus 2 to minus 12. So there are 3 parts. So we shall solve these 3 parts separately. We shall calculate heat removed during this part. Then during minus 2 degrees Celsius when phase is changing, and from minus 2 to minus 12 degrees Celsius. And this whole region is solid region, pure solid, because the complete fish is now solidified. So heat to be removed above freezing point. Above freezing point means from 5 till minus 2. At minus 2, it will not freeze immediately. It will take some time to freeze. So from 5 to minus 2 degrees Celsius, the total heat to be removed is given by, from the definition of specific heat, we know the heat to be removed for 1 kilogram from 1 kilogram of fish is this one. So for M, this much kilogram, which is 680, multiplied by C, multiplied by delta T, the temperature change. Right? So 5 minus 2. So the total drop in temperature is from 5 to minus 2 is 7 degrees Celsius. This delta T is 7 degrees Celsius. You may write it as minus 2 minus 5, final minus initial. Then the answer will be in negative. Negative is fine because heat is being removed. Okay, so you may represent it in minus, but minus here simply means the amount of heat has been removed, taken out from the system. Okay, so minus likhe ya na likhe, but at least you should know what is the meaning of minus. Okay. When you will go to the market, you will never say, I need a refrigerator of minus 3.5 kilowatts. You will always say 1 ton or 2 tons ka refrigerator chahiye. So minus, we know that it is minus because heat is removed. Right? So you may write it like this. There will be minus. You write or not, doesn't matter. हम कोई complete cycle नहीं यहाँ पे स्टडी कर रहे हैं या किसी कंप्लीट साइकिल का एनालिसिस नहीं कर रहे. इट इज जस्ट अ प्रोसेस. ठीक है, जब कंप्लीट साइकिल का एनालिसिस करें, देन वी हैव टू बी वेरी केयरफुल अबाउट दिस पॉजिटिव एंड नेगेटिव साइड्स. सो होपफुली दिस इज क्लियर कि ये जो टोटल टेम्परेचर ड्रॉप है, दैट इज 7 डिग्री फ्रॉम 5 टिल freezing point. So this is clear. MCP delta T. So that is the heat to be removed above freezing point. So that is MCP delta T, and that comes out to be 15.146. आंसर विल बी इन joules और उसको मेगा joules पे कन्वर्ट किया हुआ है, because the amount of mass is not 1 kilogram, it is 680 kilograms. That's why the amount of energy to be removed is significantly higher. So answer will be in joules because it is kilograms, kilojoules per kilograms per Kelvin into Kelvin is change in temperature. In Celsius is equal to change in temperature in Kelvin. So answer will be in kilojoules because this value is given in kilojoules, 3.182 kilojoules per kilogram. So usko phir aap megajoules में convert किया, उसे again 1000 पे divide. Right. So now then the second part, heat to be removed as latent heat at minus 2 degrees Celsius when phase is changing. Now temperature change is 0. Because at minus 2 degrees Celsius, there will be no temperature change. So we cannot use MCP delta T. Here we have to use simply M into H. This is M, total mass, multiplied by H of fusion, HFU, heat of fusion, which is to be taken out from that fish for during freezing or during phase change. So that comes out to be 159.46. Answer would be in kilojoules because the H of fusion that is given in kilojoules per kilogram. This is also clear. Now the heat to be removed from minus 2 to minus 12. Heat to be removed below freezing point, minus 2 to minus 12. So again MCP delta T, because now again it will be changing. It will be dropping from minus 2 to minus 12 degrees Celsius. So again, minus 2, so total change in temperature is 10 degrees Celsius. So that will result in 10 degrees Celsius. You may write it as minus 12 minus 2. The final minus initial. You may write it like this one. Final temperature minus initial temperature. Initial temperature is minus 2. So that will be 10. Total change delta T is 10 degrees Celsius. Right, so there will be a minus sign. So answer will be with minus sign, but we are not writing minus because we know it is heat removed. All of these are heat removed. So they are actually negative heats as far as the system is concerned. So that is the 11.676. kilojoules में आंसर आएगा, उसे 1000 से further divide किया, so answer is in megajoules जो यहाँ पे show किया. So total heat removed is the sum of these three: 15.14, 159.46, or 11.676. So the total heat to be removed is given as 186.2816 megajoules. And you can notice here, amount of heat which is removed above freezing is 15.146. The amount of heat which is removed during freezing is 159. And amount of heat which is removed in the solid region is 11. So you can see here, this is the major amount of heat which is removed when there was no change in temperature, only phase was changing. So this is the largest amount. If you neglect this thing, so you can imagine your result will be totally wrong. If you neglect this heat, this latent heat has the largest part. So to remove this heat from 5 degrees Celsius to minus 12 degrees Celsius, the total heat to be removed is this one, 186.2. Now, if you want to remove this heat in 1 hour, so you will divide it by 3600 seconds. So you will find the answer in watts or kilowatts or megawatts, etc. If you want to remove this heat in 2 hours, so it will be 2 into 3600. So then you will have a different wattage because the wattage will reduce. So accordingly, so depending upon our requirement, this is the total amount of heat to be removed. Now it's up to us okay, whether we want to remove this heat in 1 hour or 2 hours or 3 hours or 4 hours. So accordingly, the total wattage will be reducing. Second part भी इस क्वेश्चन का कि what percent of this heat, what percent of this total heat is latent heat. इस पूरी total heat का जो latent part is this one. So it means latent part is 159.46 divided by total heat is 186.28. That is the percentage of latent heat which is removed from this total. So that is 85.6%. 159.46 divided by 186. The amount of latent heat which is removed out of this 186 is 85%. So now you can imagine from -5, +5, -12 degrees Celsius, there is this heat, latent heat at -2 degrees Celsius. If you neglect this heat and if you only use MCP delta T, your answer will be wrong, hugely wrong. 85% of heat was neglected. So latent heat is not at all negligible. Okay, so any question from this problem?
सही जो लास्ट में आपने परसेंटेज निकाली कहानी से दोबारा रिवाइज करवा दें.
Percentage of latent heat out of this total heat. ये total heat remove की हमने फेस से. Above freezing point this one, below freezing point is this one, or during freezing is this one. So during freezing represents the latent part. So this latent part is 159 divided by total 186. So that is the percentage of latent heat which is removed during phase change. Or phase change कब हो रहा है? At freezing point. Freezing point of fish is -2 degrees Celsius. So that is 85.
सही. Okay, thank you sir.
Okay, so let's solve another problem. So now you repeat. जितने भी problems हमने solve किए, every problem is different from the other problem. अब let's solve another problem. एक और problem solve करते हैं. अब इसमें आप देखेंगे the situation is totally different. A mass of 0.05 kilograms of a fluid is heated at a constant pressure of 2 bar. So we are heating that fluid at a constant pressure, it is important, of 2 bars until the volume occupied is 0.0652 meter cubes. So it means that is V2, because of the heating start, V1 is not given here, V2 is given, or capital V2 given because it is not meter cubes per kilogram. So that is V2. Constant pressure heating means from state 1 to state 2, pressure is constant. And that is the mass. So we are studying closed systems. So that's why mass will be a constant. So M1 is also equal to M2. Calculate the heat supplied and work done during this process in which fluid is heated at constant pressure. Its volume is changed to this volume. And during this process, so for example, it is like this one, some closed mass, M, it is heated at constant pressure. So it means it can expand, right? So it can expand. So this was, for example, state 1, this is state 2. So for state 2, this V2 is given. There is no information about V1. V1 nahi given. And during this process, there is certain amount of heat was transferred, so that is to be calculated. And this fluid has done some work also. So that work is also to be calculated. ये problem है. So what is the part one? Part one is when this fluid, ये जो fluid है जिसको हम heat transfer कर रहे हैं and it is expanding. If this fluid is steam, initially dry saturated. So you should be clear what is meant by dry saturated. Okay, resume TV या PV because we want to find out work done, so it's better to show it on PV diagram. So where is dry saturated? This whole region is saturated region. Starting from here, ending here. So this whole dome or inside the dome, this whole portion is saturated. Now where is dry saturated? So any point on this saturated vapor line is known as dry saturated. This is also dry region, but that is not saturated. That is superheated region. So dry saturated is only this one. This is not dry saturated. It is saturated, but it is liquid. It is not dry. It is wet. Wet region. Starting from here, ending here. At this point, anywhere on this line, this is dry and saturated. Okay. So इस point से हम आगे further जाएं, so it will be superheated. इससे वापस इस तरफ आए, so then it is mixture or wet region, because now there will be steam in liquid phase also. So now when the part one is when this fluid is steam, initially means V1. So this V1 is anywhere on this point, because here likha hua hai when the fluid is steam, initially dry saturated. So let's show it somewhere. For example, this is state 1. We don't know exact location. I mean, ye known hai that it is somewhere on this dry saturated. Now it is heated at constant pressure. So it means when it is heated, it will go in this direction because volume will expand. Pressure is constant. So until its volume is this one. That volume is given. That volume is V2, which is given 0.0658. 0.0658, that is given. Right. So now we need to find out the heat transfer during this process. 1 to 2.
आपकी आवाज नहीं आ रही. हेलो.
जी आवाज आ रही है बाकी सबको?
यस सर आ रही.
यस सर आ रही है.
यस सर.
ओके ठीक है. जिसे नहीं आवाज आ रही he will have a recorded lecture. ठीक है, या अपना इंटरनेट कनेक्शन देखें या अपने कंप्यूटर की सेटिंग्स देखें. ओके जी. So this is the process 1 to 2 on PV diagram, and area under this process represents work done. This is the work done. ठीक है. Area under this process on PV diagram does not represent heat transfer. ठीक है, heat transfer हमें find करना है. So that is the diagram for this question. That is the stoichiometric diagram. This one is stoichiometric diagram, and this one is property diagram. Okay. So now we need to find out heat transfer and work transfer. So if it is clear, show the solution now. The diagram separately यहाँ पे show हो रही है. This one. ये जो मैंने यहाँ draw किया. So here is the pressure which is given. E1 is equal to P2. Now we need to find out V2 and V1 to find out the work done. And heat transfer is given by, heat transfer during this process is given by change in enthalpy H2 minus H1. H2 minus H1 will be heat transfer, because जो heat यहाँ transfer हुई है during this process is not only changing its temperature, means U, it is also doing some work. So the total heat transfer हुई है, that is actually U plus PV, because there is PV work done. So U plus PV is enthalpy. So during this whole process, the total amount of heat which is transferred is given as H2 minus H1. So initial state was dry saturated at 2 bars. This was initial state. So at this point, we can find out H1, which will be equal to Hg at 2 bars. Because it is steam, so we cannot use ideal gas equation. We have to rely on the steam table or experimental data. So H1 is equal to Hg at 2 bars. So we can go to the table to find out H1 is equal to Hg, right, at 2 bars. So 2 bar के ऊपर you can read Hg value directly from the table, steam table. 2 bar means 2 into 10 to the 5 pascals. So table में अगर किलो पास्कल में है तो इसे divide करें 1000 से, so answer will be kilopascal, 2000 kilopascals. So at 2000 kilopascal, you can read Hg value, that is 2707 kilojoules per kilogram. Now, we can also read Vg value at this pressure. At 2 bars, again from steam table, that is 0.8856 meter cubes per kilogram. Right. Now, this is H1. Now we want to find out H2. V2 is already given. Capital V2 is given, right? So now we can find out small v2 because capital V divided by m, which is 0.05 kilograms. So we can find out this small v2, specific volume at 0.2, that is small v2, 1.316 meter cubes per kilogram. And this 0.2 will definitely be in superheated region, that is a superheated steam. Right. So to find out the heat transfer, we need to calculate H2, just like H1, because H2 minus H1 will be the heat transfer during this process. Then P into V2 minus V1 will be the work transfer. So V2 and V1 are known. This is V2, this is V1, which is Vg, and pressure is constant. So P into V2 minus V1 is the work done. Now to find out heat transfer, we need to find out H2. So now this region is superheated region, so we'll go to the superheated table. So here is the superheated table at pressure of 0.2 megapascal, which is given. At this pressure, what is given? Volume is given, 1.316. So we'll see in this table, where is this volume? 1.316. 1.316. So here is the 1.316. At this pressure, here is this volume. So fortunately here the volume is, so you can neglect the last 2 decimals because until 3rd decimal it is correct. So we may neglect this one. Agar ye volume kahin somewhere between these 2 of them, then you have to interpolate between these 2 volumes for this pressure to find out H. Okay. But here at this volume and at this pressure, we can directly read H2. Right? And we can also read temperature. Temperature will be 300 degrees Celsius. Or yes, saturated. The first line that is saturated point data. So you can find out the Vg from here also, from superheated table and also from saturated table, because superheated table starts from कहाँ से होता है superheated table from the saturated point onwards. So saturated point, saturated vapor values के जो saturated vapor के corresponding thermodynamic properties, those are given here. So state 2 के लिए what was given? Pressure and volume. So corresponding to this pressure and this volume, this will be temperature, this will be internal energy, and this will be enthalpy. So we want to calculate enthalpy. So here is the enthalpy for 1 kilogram, 3072. Right. So let's go back. So now we have calculated from superheated steam table at this pressure and at this volume V2. T2 and H2. So we need H2 to find out heat transfer. What is heat transfer? Q is equal to H2 minus H1, capital H2 minus capital H1 is equal to M into small h2 minus small h1. ये M is known, that is 0.05. H2 भी known हो गया, which we have seen from the table for 1 kilogram minus H1, which is equal to Hg from superheated table or from saturated table. दोनों table में से आप you can find out this H1 is equal to Hg. So just values put here. Kilograms into kilojoules per kilogram minus again kilojoules per kilogram. 3072 minus 2707. So the heat transfer is given by 18.25 kilojoules. Answer will be in kilojoules because here M is not M dot because M is fixed. It is total M kilograms. Kilograms multiplied by kilojoules per kilogram. So here is the kilojoules. Now work transfer, work done is simply given by P into V2 minus P V1. So here is pressure, which is constant. Pascals में Newton per meter square into meter cubes per kilogram V2. Where is V2? This was V2. This is V1 0.8856. So here is the work done 8606 Newton meter means joules. So this term is actually joules per kilogram. Okay. और आप इससे मल्टीप्लाई करें m से भी, because यहाँ m से मल्टीप्लाई नहीं किया हुआ, so you may multiply here or in the next step m into the total m is also given, so that is 4.3 kilojoules. So work done is less than heat transfer. And that should be like this because जितनी heat transfer हुई उसी का कुछ part convert हुआ work done. The rest was only used to raise its temperature from point 1 to point 2. So this was part 1 when the fluid was steam and initially dry saturated. Any questions from this part? Okay, so no question. कोई क्वेश्चन नहीं है तो नेक्स्ट वीक एग्जाम है, देन वी विल बी आस्किंग क्वेश्चंस, अनसीन क्वेश्चंस होंगे दिस टाइम, सो prepare well. Okay, let's solve part 2 when the fluid is air. Part 2 में, now it is not steam, it is air. It means in this region initially at 130 degrees Celsius. So now there is no need to show dome for part 2. Let's solve part 2 when the fluid is air. So here you can see there no dome is shown because it is air, definitely in the superheated region. So it means there is dome, but our region is far away from this dome. So initially at temperature, so initial temperature, so this is PV diagram, and in the gaseous region, what are these? These are temperature lines. The temperature, this is T1 line, this is T2 line, this is T1. The rest of the data is same. Again, same 0.05 kilograms of mass. Pressure is constant, 2 bars, or 2 into 10 to the power 5 Pascal. Final volume is given, V2. So now again, we need to find out heat transfer and work transfers. So now there is no need to use a steam table. We can directly use equations because it is ideal gas, which is air. Air is ideal gas under these temperatures and pressures. Okay. So how to find out heat transfer? Heat transfer is given by H2 minus H1, and what is enthalpy change is actually MCP T2 minus T1. We have already stated change in enthalpy is actually change in specific CP into T, change in heat transfer in terms of CP delta T, CP. So here there is no need to find out H1 and H2 from any table. We can directly use this equation. mCp into T2 minus T1. Here Cp we shall assume constant for this, from this point till this point. So here the Cp will be given. These question may mention nahi hai, but Cp of air should be given. And also in this equation, T2 is to be calculated. T2 is not given. Okay, so and also T1 be given. T1 is given 130 degrees Celsius. That is T1. So T2 is to be calculated, and we can use ideal gas equation because it is air. We cannot use this equation in part 1. Right, so values put करें. P2 is equal to P1 2 into 10 to the power 5 pascals. V2 is given 0.0658. What is M? 0.05. R 287 if it is pascals. Yeah, otherwise 0.287 if it is kilopascal here. So here it is pascal, so that's why it is 287 or 0.287 into 10 to the power 3. That is gas constant for air. Okay. So from here we can find out temperature. Temperature will be in kelvins because it's a single T. Answer will be in Kelvin by default. Right. So T2, T1 both are given. So T2 minus T1. ये Kelvin में है तो इसे भी Kelvin में ही शो करें. 130 plus 273. Cp of air is 1.005 kilojoules per kilogram per Kelvin. And so that is the heat transfer. Now we need to find out work done. Work done is given by M into small p into V2 minus V1. So these are also small because M is written outside. So here again, we can write this in this form. PV is equal to MRT or PV is equal to RT. So M into R into T2 minus T1. Pressure is constant. From 1 to 2, pressure is constant. So PV2 can be replaced with RT2 and PV1 can be replaced with RT1. R is taken out. Right? Because we know T1 and T2. T1 be given a, T2 be given a, so we can replace this P into V2 minus V1 as R into T2 minus T1. So just values put there. R, T2 minus T1 and kilojoules per kilogram. So into 0.05, which is the mass M. So that is the work done during this process. आप इस V2 minus V1 से भी find कर सकते हैं. First, you need to find out V1 using this equation. V1 is equal to PV is equal to MRT. से you can find out first V1 and then you have to find out V2. V2 is equal to MR because V2 is actually given. V2 is already given. This is capital V2. This V2 divided by M is this one. So you can solve it either using this equation or using this equation. Right, so this was part 2 without using any steam table. Just we can use equations in case of ideal gas. Any question? Please ask. कोई question नहीं है? Okay. So let's solve one more problem. 50 kilogram iron block. 50 kilogram iron block at 80 degrees Celsius is dropped into an insulated tank that contains 0.5 meter cubes of liquid water. So let's draw its schematic diagram. So 50 kilogram iron block, 50 kg iron block is dropped into an insulated tank. ये एक insulated tank है जिसमें इसको drop कर दिया. And this tank contains 0.5 meter cubes of water. जिसमें आपने इसको dip कर दिया है. This tank contains water. How much water? 0.05 meter cubes of water. So the liquid water का initial temperature is given as 25 degrees Celsius. The initial temperature of iron is given as 80 degrees Celsius. Okay, initial temperature of iron is 80 degrees Celsius. Initial temperature of water is 25 degrees Celsius. Now, after some time, what will happen? The temperature of this iron will drop and the temperature of this water will increase until an equilibrium is achieved, a thermal equilibrium. Both iron and water will be at same temperature. And we need to find out that final equilibrium, determine the temperature when thermal equilibrium is reached. So what do you think? What will be the final temperature, near to 80 or near to 25?
Near to 25, sir.
Near to 25, Achha. Or yes, somewhere in between 80 and 25.
So between 80 and 25. 80 drop and 25 rise.
Yani somewhere in between 20 and 25 and 80. So anyone who says that near 80 hoga, final temperature 70s में होगा या 60s में होगा. So one student is saying it near 25 hoga, second is saying it is somewhere between 80 and 25. So let's solve it. Again, you can see कि इस problem की statement कितनी different है जो हमने दो previous problems किए हैं. हर problem, every problem is totally different from each other. That is the major issue in thermodynamics. और thermodynamics one में और कोई issue नहीं है. यही main issue है. You have to practice each and every numerical problem. Every problem is different. Okay. अब इस problem को कैसे solve करें? So there is energy transfer. Insulated tank है, so no energy can cross the system. So now let's see that this tank is our system. So you see system, within this system, this process has occurred. If we consider this whole tank as our system. So solved example है आपके book की. So वहीं से मैंने इसका solution upload किया है यहाँ पे. So this is the iron block, 50 kilogram weight, 80 degrees Celsius temperature. Water का initial temperature 25, water का volume given है. So now let's apply first law, energy balance, to this system. What is the system? This entire tank is our system. So let's write the equation, energy balance equation. What is energy balance equation? E in minus E out is equal to delta E of system. So what is energy entering into this system? Is there any energy entering the system? If this is our system and this process is occurring, any energy which is crossing the system boundary, because this is insulated tank, there's no energy crossing the system boundary. Any energy leaving the system boundary. कोई एनर्जी लीव कर रही है इस सिस्टम से. So
No,
this
sir.
is 0, right? This is 0.
So later tank.
0. So it means delta E of system is equal to 0. इस सिस्टम की ये इक्वेशन है. Delta E of system is equal to 0. Everything is 0. So what is delta E of system? Now system consists of, within the system, there is some energy change. और वो जो net change है that is equal to 0 because nothing is crossing the system boundary. जो भी change हो रही है वो within the system हो रही है. System consists of two parts. ये जो delta E of system है, it consists of two parts. Delta E of water भी उसमें involved है, plus delta E of iron. That is equal to 0. Delta E of system, which consists of two parts, delta E of water plus delta E of iron, that is equal to 0. what is the change in water? Delta E में which change is significant? एक तो delta U होगा. Change in kinetic and potential energies are negligible. So delta U of water plus delta U of iron delta is equal to 0. And what is delta U? C delta T, MC delta T of water and MC delta T of iron. Cp and Cv are same because ये एक liquid है, दूसरा solid है. So Cp and Cv are same. So it's simply this change in U is equal to MC delta T of water plus MC delta T of iron. That is equal to 0. And what is delta T? Final minus initial temperature, T2 minus T1. This is also T2 minus T1. Water के केस में what is T1? 25. Iron के केस में what is T1? This T1 is 80. So T2 will be same. यही T2 unknown है because after when thermal equilibrium is achieved, this T2 of both iron and water will be same. So इस पूरी equation में T2 is unknown. M of iron block is given. M of water आप find कर लेंगे from density of water multiplied by volume of water. Volume of water is given 0.5 meter cubes. Density of water is 1000 kilograms per meter cube for liquid water. ठीक है. Density से find कर लें या 1 over V, 1 over specific volume से of water, liquid water. ठीक. C of water वो टेबल से देख लेंगे 4.2 किलो जूल्स पर किलोग्राम. सिमिलरली C of iron वो भी टेबल से या गिवन होगा. ठीक है. So that is the equation which we need to solve. और इसमें there is only one known and that is T2. So ये पूरा solution यहाँ हुआ है. Solved example है. So the final temperature is 25.6. So the answer is the final जो T2 है that is near to 25. Now why? What is the reason? That is important.
Specific heat से
Yes, specific heat. Specific heat of water is very low. 4.18. बिल्कुल बिल्कुल. और जो आयरन की है that is only 0.45. और also mass of water. Mass of water is 500 kilograms. जो mass of iron. So MCP of water is significantly greater or higher than MCP of iron. That's why the final temperature is near to water and not iron. Okay जी. So now we have 4 minutes remaining. फिर आपका क्विज होगा, ऑनलाइन क्विज. आप सब लोग गूगल मीट पे ऑनलाइन ही रहें. ठीक है. कोई गूगल मीट से आउट नहीं होगा. और मैं क्विज अपलोड करूंगा.
सर MCQs होंगे.
MCQ टाइप होगा. ठीक है. तो लेट्स सी आप सब लोग जितने हैं यहाँ पे. नो वन विल लीव दिस क्लास. ठीक है. यहीं पे रहेंगे. और जब कोई स्टार्ट होगा आप ऐसे कीजिएगा, आप सारे अपने माइक्स भी ऑन कर लीजिए. ठीक है. When quiz will start, all of you will switch on your mics also. ठीक है. कैमरास का मैं भी नहीं आपको कह रहा. मैं वैसे एक्सपेरिमेंट कर रहा हूँ आज के क्विज में. तो सिर्फ आप अपने माइक्स ऑन कर लीजिएगा. अभी 3 मिनट्स रहते हैं.